Okay, here we go. Thanks for tuning in. Here's the solutions to the practice quiz for tomorrow's test. First one, this whole group of problems here, you're only deciding if it's a geometric or arithmetic series and then figuring out what the nth term equation is for each one. First one's geometric. You can see it's not going up by the same amount every term. Turns out to be geometric where the ratio is 1.5. So our equation then is a sub n equals 12 times 1.5 to the n minus 1. Next one's arithmetic. We're adding 20 every term. And so we've got a sub n then equals negative 32. That's our first term. Plus n minus 1 times 20. That's the standard sort of math book way to write that equation. You could use this method here, which is a much cleaner way to write that equation, 20n minus 52. But I'll accept either one on the test. Next two are both geometric. And number 3, your r value may not be real obvious what it is just by looking at the numbers, but you can always find the ratio by dividing any term by the term in front of it. So if I divide 14 by 17.5, I get 0.8. That's my ratio. So the equation is a sub n is 17.5 times 0.8 to the n minus 1 power. Next one is geometric. You can tell that it's being multiplied by negative 3, positive 3, negative 9, positive 27, etc. So r is a negative 3. So don't forget about that when you write out the equation. 3 times negative 3 to the n minus 1. Next problem, a couple problems there about finding the sums, and here it is in sigma notation. So we're starting with our index at 1 and going to 20, so that's actually 20 terms. So n is equal to 20 in our formula. And so our first term is where n equals 1, and if you put a 1 in there, you get negative 3. And our last term is what you get when you put in a 20 for n. So first term's negative 3, last term's 35. So we could use this formula right here that uses the first and the last terms. And so you're just putting the numbers in here, multiplying it all out, order of operations, blah, blah, blah. You get 320 as the sum. Next one, a little typo there that should have been plus in between each of those instead of commas. Anyway, it's a sum of all those numbers, and I have determined that there are 7 terms in this sum. So n equals 7 and r equals 1.5. We had a long discussion about how you determine that in class today. There's basically 2 ways. One of them is using the actual nth term formula for a geometric sequence and solving for n. It can be kind of tricky. Another way, which sounds kind of caveman dumb, but it works, and that is just to start multiplying your initial value times your ratio. In this case, it's 1.5. So 100 times 1.5 times 1.5 times 1.5 a bunch more times until you get this number here, and hopefully you were counting and you can tell how many terms there are that way. Sounds kind of dumb, but it works. Anyway, here's our sum for partial sum for a geometric sequence right here is our first term. 1 minus the ratio to the 7th power like that, and all this stuff works out to be a nice friendly 3,217.1875. Okay, the next problem, find the sum of the first 1,000 odd numbers. Okay, that's 1, 3, 5, etc., all the way up to the 1,000th odd number, which quite honestly, I'm not really sure what it is. It's probably around 2,000, but I don't know if it's 1999 or if it's 2001 or something like that. So let's try to figure it out. I know the first term is a. I know the common difference is 2. It's an arithmetic sequence. I'm adding 2 every time. And I know that there's 1,000 of them. So n equals 1,000. So if I figure out, actually I don't really need to figure out what the last term is if I use this other formula for the sum that uses the first term and the common difference and the number of terms. So it's kind of a complicated looking formula, I suppose, but you just plug those values in and you get a cool 1 million as the sum of the first 1,000 odd numbers. Alrighty, next one, you're finding the 7th partial sum of this arithmetic sequence in which a, the first term, is negative 5 and a sub 7 equals 16. So n equals 7. A sub 7 is the 7th term, and so there are 7 terms. We're finding where a is negative 5 and a sub 7 we got. So all we have to do is use this formula right here, the same one that we used up there in number 5, because we got the first term and the last term. We have n. It's pretty easy. So that turns out to be 38 and a half. This next sum here. Our first term is 0.2, next term is 0.4, then 0.8, so we're doubling each term. So our common ratio is 2, and you can figure out that n equals 10. Watch this. So here's our nth term rule. A sub n equals a times r to the n minus 1. We got 102.4. I want to know what term that is. So when I set this equation up, all right, that's just my nth term equation using for this term here. Divide by 0.2, you get 512 equals 2 to the nth power. 512 is 2 to the 9th. So 2 to the 9th is 2 to the n minus 1. That means 9 equals n minus 1. Therefore, n equals 10. So you got to be careful there that you're not off by 1, because it does make a difference. So anyway, now we're ready to use our partial sum formula for a geometric sequence there. And we've got all these numbers cranking out to a nice 204.6. Okay, so there's that. Let's flip it over, do the next problem here at the top of the page. Find the sum of the infinite geometric series. 4, 3, 2 1/4, 1 point, okay, you get the idea. You can figure out the r is 3 divided by 4, that's 3/4. Our a value is 4, so this is a really easy formula to use. You end up with 16 as the sum of that infinitely long series. Kind of mind-bending, actually. All right, the common ratio of a geometric sequence is -3, and a sub, what is that? I'm sorry, what number is that? I can't read that. A sub 5 is 27. Find a sub 2. So we've got 27 equals I'm sorry, that's a 6. A sub 6 equals 27. So n minus 1 is 5. And so we're finding the first term here. Since we know the common ratio is -3, we work this one out. We get a actually is -1/9. That's just a sub 1. I want a sub 2, so I'm going to take that -1/9, multiply it by -3, and that gives me +1/3 for a sub 2. The next problem, find the nth term of this sequence where -15 is the first term, and 20 is the 6th term, okay? So 20 is the 6th term. So I know the first one, so I'm going to use my nth term equation structure right here. 20 is -15 plus n minus 1, and that'll be 5. And so you add 15, you get 35 equals 5 times d, so the common difference is 7. So now we can write the equation. Once again, here's kind of the textbook style of this equation, and if you want to clean it up, 7n minus 22 is a better way to write it. Okay, let's see, iPad's getting heavy here, it's starting to wobble. Here's find the common ratio of this sequence that doubles every 12 terms. All right, so if a sub 1 is 1 and a sub 13 is 2, okay, so it's doubled after 12 terms, we'll solve for r. It's pretty simple, actually. That means 2 equals 1 times r to the 13 minus 1. That means 2 equals r to the 12th, and that just means that r is 2 to the 1/12th power, or the 12th root of 2. If that sequence started with a sub 1 equals 440, what would a sub 7 be? All right, so there's 7 minus 1 is 6. 2 to the 1/12th raised to the 6th power is 2 to the 1/2, or the square root of 2. So it's 440 times the square root of 2, which is about 622.254. All right, Dr. Awkward's weight loss clinic is expanding and going nationwide, and he gets 11 more clinics every month, starting with 3 in the January of this year. If the rate of growth does not change, how many clinics will be open by the end of next January? All right, so we start off with our sequences 3, next one is 14, next one's 25, etc. Okay, it's an arithmetic sequence, so here's my arithmetic sequence structure. I've got n minus 1 times 11. I'm actually trying to figure out, so that's the structure right there. If a sub 13, I don't know what that is. So a sub 13 then would be 3 plus 12, 13 minus 1 times 11. That gives me 135. So my last month, I'm opening 130, or Dr. Awkward is opening 135 clinics. So we can put those numbers, our first term, our last term, into our partial sum formula. We get 897 clinics. Okay, last problem is a joke, and you're explaining the joke. The joke is an infinite number of mathematicians go into a bar. The first one orders a pint of root beer. The second one orders half a pint of root beer. Third one orders a quarter pint of root beer. And the bartender is also a mathematician. He says, okay, I get it. And he pours 2 pints. That's the joke. If you're a mathematician, you're supposed to laugh after that. And so the bartender recognizes that there's an infinite sequence going on, 1, 1/2, 1/4, 1/8, etc. And since he's only concerned with selling root beer, he determines that the sum of all the root beer sold will be 2 pints, because that's the sum of that infinite series. He pours that and leaves it to the customers to do the dividing. After all, they are mathematicians. Okay, there you go. Hope you got all those solutions down. See you soon.